In Algebra 2, we start using polynomial long division to find what a ratio of two polynomials will end up being. The purpose for this before was also finding zeros of polynomials, but now I'm going to model long division to find slant asymptotes. So I have a polynomial, or I have a rational function. It's a polynomial divided by a polynomial, and I'm going to use long division. So x minus 1 becomes my divisor, and then x squared plus 3x plus 5 is my dividend. And it's like long division when you did long division without variables before. You just have to be a little bit more careful. And there's two terms for the divisor. So I'm only looking at the first term. I only want to take the x. And I want to know how many times x will divide into x squared. So I think of it as x squared divided by x. That's equal to x. So that's what's going to go here for the quotient, an x. And I keep it in the same place value. If it were x squared, I'd put it above here. But this is just an x, so I'm putting it above there. Then I'm going to multiply. But I'm going to multiply x times x first, and I get x squared. And then I multiply the x and a negative 1, so I get negative x. In long division of numbers, the next step is to subtract. So I'm going to subtract these. But I have to be careful. X squared minus x squared is 0. 3x minus a negative x will give me a 4x. I'm going to bring down the 5. It gives me plus 5. And then I do division again. So x, I want to find out how many times x divides into 4x. So I think of it as 4x divided by x, which is 4. So that's what's going to go here in the quotient. I get x plus 4. The 4 is going to get multiplied by the x, and the 4 gets multiplied by the 1. And then I subtract them. 4x minus 4x is 0. 5 minus negative 4 is 9. The 9's irrelevant when we're looking for slant asymptotes. My slant asymptote is actually going to be just my quotient. So my slant asymptote will be y equals x plus 4. To show you how that works on the calculator, I'm going to go to my y equals, and I'm going to graph the equation that I started with. So x squared plus 3x plus 5 over x minus 1. And what I found when I graphed this is I can't see the whole graph, so I'm just going to zoom out so I can get a better picture of the whole graph. This graph has a vertical asymptote at x equals 1. There will not be a horizontal asymptote because the degree in the numerator is larger than the degree in the denominator. And you can see right on here how it curves up. So what I am going to show you is then I've got the asymptote is y equals x plus 4. And now when I go to graph that, you can see in the red line is the asymptote. And it runs right along where the function goes. So that's a way you can check it. Let me do one more example. If I had a function 2x squared minus 7x plus 8 divided by x plus 3. X plus 3 becomes my divisor. 2x squared minus 7x plus 8 is my dividend. So I'm going to take 2x squared and divide it by x, and I'm left with 2x put above the x value. 2x multiplied by x will be 2x squared. 2x multiplied by 3 is plus 6x. Then I'm subtracting. 2x squared minus 2x squared is 0. Negative 7x minus 6x will be negative 13x. I'm going to bring down the positive 8 and then do division again. So x divided into negative 13x will be negative 13. Negative 13 multiplied by x will be negative 13x. And negative 13 multiplied by 3 would be negative 39. Carefully subtract those two terms. Negative 13x minus negative 13x is 0. 8 minus a negative 39 becomes 47. I don't care in this instance about the remainder, but the slant asymptote becomes y equals 2x minus 13.